Welcome, Tactical Technician Diag Nation here. Today's video is called Scope and a Load Pro. I just want to tell you, with this technique, we're going to be in a situation where we're going to test a circuit with our consumer disconnected. In this case, it is the fuel pump. And there are times when we have to test things where we're not sure the condition of the load, whether it be a fuel pump, a cooling fan, an ignition coil, an injector. And if we check open circuited, we have to get current to flow so we can prove out the circuit, the integrity of the circuit, where there's no unwanted resistance, which creates voltage drop in the circuit. So with this technique, we have the scope on two channels. Channel A blue is across the connector on the harness side of the car at the fuel pump, the power side to the fuel pump and the ground, as you can see there. Channel B is an amp clamp. And the reason I use an amp clamp is it's sort of a validator that we could see current flowing when we activate the Load Pro. And that sort of, that gives us you can see the difference between testing a circuit without a Load Pro and testing a circuit with a Load Pro. Because if we have unwanted resistance and we don't have a Load Pro on an open circuit, we're not going to see the voltage drop. We don't want to get burned on a misdiagnosis of missing a resistive circuit when we're testing something. One more thing right here, the fuel pump relay. For this demonstration, I've latched that thing, I latch it all the time for the demonstration. So I will be testing key on, and in a natural state on a car, that thing usually latches for about 2 seconds and then shuts off by the PCM. Just bear in mind that when you're testing a car, any kind of consumer, most things have relays that send them power. Cooling fans, PCMs, fuel pumps, injectors, coils, things like that. Bear in mind that the relay itself could be the cause of the voltage drop, and that's something you gotta bear in mind. Using this technique with the Load Pro will find voltage drop. You just got to go out and find where it is in the circuit, but that'll tell us if there is voltage drop in the circuit. So over here is our kind of our tool bench, just to give you an idea of, makes it a little easier understanding what we're using. The blue lead on channel A is going to be at the fuel pump, the blue lead at the power side to the pump, the black lead at the ground side of the pump on the connector, the harness side, not the fuel pump, which is disconnected. These are double stacked banana leads, and they give us the advantage of hooking in more than one thing to the test lead. In this case, we got the test leads in the front, and we got the Load Pro in the back side of the double stack. So that's basically our test light with a switch right there that I can control that, so I can make current flow in the circuit to fish out any voltage drops. One more thing right here for the Snap-on users, that can be used. You can use this on a Snap-on scope or a DVOM with the double stack banana leads right there. That is basically a double stack banana to a BNC adapter. So let's go to the car and get onto the scope and see if we're going to create different situations to show the value of the Load Pro, how it will fish out any unwanted resistances in the circuit. As I told you on this, I don't know if I mentioned it before, if you look at your schematic, I will create resistance. I can insert resistance or I could remove resistance at my free will to show you the effect, how efficacious the Load Pro is at finding voltage drops when they're there. So the first thing I'll do is I'll turn the key on, and I'll start the scope, and we'll take 1 second at a time. The scope is on. I will turn the key on, and we got our basically our voltage rise. That's voltage at the fuel pump. We can see we have no current flowing, and in a diagnostic realm, this is sort of, it's okay. It's not perfect. It's not foolproof. We can get burned on a voltage drop like this. We have to get current flowing in the circuit. So let me just stop the scope, and we'll kind of analyze how much voltage we're seeing right now. Okay, this is about, I guess, about 12.29 volts. That's basically our open circuit voltage at the back there at the fuel pump connector with no current flowing. I will, right now I'm going to start the scope. I'm going to turn the key on, and I will insert that resistance into the circuit. and we'll see what happens once I insert that resistance into the circuit. Okay. Key on. Our voltage is up. We have no current flowing, and I will insert resistance right now. Here we go. Resistance inserted. You see nothing. Resistance inserted. There's no difference. It did nothing. We have about 4 ohms of resistance in that circuit. Those are the green crusties in your schematic. So bear in mind something, that I'll stop the scope. We have the same amount of voltage we had when I initially ran the test without resistance. So if we were diagnosing only with this method, we would get burned. We would miss that resistance. And if we put a new fuel pump on and there is excessive voltage drop, it won't perform optimally. So there's something to bear in mind. So my next step, I'm going to do something here. I'm going to turn the key on. I'm going to take the resistance back out of the circuit and make the circuit normal again. Start the scope. Okay. The key comes on. Okay, we got our circuit, we got our voltage here. I'm gonna add the Load Pro, and just the Load Pro. I'm gonna close the switch on the Load Pro, and we're gonna see what happens. Okay, right there. I got the switch closed on the Load Pro. So let me stop that. Let me do it one more time just to see a difference. I want to see. Okay. All right, I stopped the capture, and you can see something here that right here is when I closed the switch on the Load Pro and I made current flow in the circuit. So we got about 2.7 amps flowing in the circuit, and that will kind of litmus test or integrity test our circuit, so we're going to see voltage drop. If we look at our voltage before I close the switch, we're looking about 1201. Right when I close the switch, we drop a little bit of voltage. There's a difference. I'll get the delta with the cursors and show you basically what that is. Okay, that's right here. That's our 402 millivolts. Okay, let me get some power on this iPad. Just bear with me. I'm just going to kind of complete this thing. Okay, hang on. Okay, we're rolling. We just had to hook up a jump pack to the iPad to finish this thing. We don't make this thing come to fruition. Okay, so you see that right here. That's basically our voltage drop. That's a normal voltage drop of our circuit. That would tell us that we have current flowing through our load, which is the Load Pro, and that we've dropped this much voltage. It could be, that's the voltage drop of the entire circuit, from the positive battery terminal through the ignition switch, through the fuse box fuel relay, out to the pump, and then on the ground back to the negative side of the battery terminal. We're going to say that's normal. So let me close everything down. And I'm going to do something now. Now I'm going to take the Load Pro out of the circuit, and I'm going to add resistance into the circuit, and then I'll add the Load Pro, and we'll see what happens then. So here we go. We're running. We got, let me get the key on. Okay, voltage is up, no current flowing. I will add resistance. I'm adding resistance. I'm sorry. Okay, I just added resistance. Okay, nothing changed because we got no current flow. Now I will activate the Load Pro, and we'll see what happens. Okay, it'll reach its sort of state right here. We got the Load Pro closed. I will stop the scope. I will turn the key off, and then we'll kind of analyze what happened. With the Load Pro and the resistance, with the Load Pro closed and the resistance, we flow less amperage because we're dropping voltage across our resistance we're trying to find in this circuit. So our voltage went down. As you can see that, it went from here, which is about 12.22 to our, How low did it go? Okay. Went down to about 4 point, what is that? There's 4.72 volts, or look at 4 and change. That is not enough voltage to run the fuel pump. So the effect of our Load Pro, what it did, it sort of gave us a validation that we're going to have to test circuits with current flowing, and the circuit had an issue. It had resistance, and when we turned it on, we dropped voltage across that resistance, and we saw what was available at the fuel pump, which is definitely not enough. So I'm going to do one more thing here. I'm going to kind of do in one scope capture. I'm going to basically I'm going to toggle the resistance on by itself, and then I'm going to toggle the resistance and the Load Pro in harmony to see the effect of a voltage drop when we flow current through a circuit with resistance. So I'll turn the key on. Okay, we're voltaged up. We'll turn the Load Pro off. Okay, we got no current flow. We got our system voltage right here. I will add the Load Pro. And then right now I'm going to toggle the resistance on and off. This is kind of the meat and potatoes of the methodology. You can see right here, low voltage, current goes down, available voltage goes down. Resistance goes back. I take the resistance away, voltage goes up, current goes up. Add resistance, current goes down, voltage available goes down. You can see how valuable this technique is if we had resistance in a circuit and we want to flow current just to kind of fish that resistance out. So one more time, we have resistance in a circuit right here. We're flowing less current. Our voltage available is less. We take the resistance out, voltage goes back up, current goes back up. So just bear in mind that this is a really good technique to flush out voltage drop on a circuit if we were testing something with the component disconnected. Anyway, thanks for watching.